Hi, I'm going to be talking to you about the bubble sort algorithm. The bubble sort is an iterative algorithm, which means it carries out its purpose using loops, and its purpose is to sort data. You see, I've created some pseudocode for a bubble sort and put it into a function. Remember, a function is a subprocess that provides or returns a value at the end of its run. Here, the bubble sort also has a parameter, data. So when I call bubble sort, as you can see from the left-hand side, I have numbers equals bubble sort, and then in brackets, numbers. When I call it, it's going to return back the sorted value. So the parameter I give it will be the array numbers, which has the values 27, 21, 12, 41, 38, and 5. The bubble sort will then sort that data and return it back in ascending order. So by the end of this run, the array numbers should hold the same data, but in ascending order of 5, 12, 21, 27, 38, and 41. Right, so I'm going to talk through the bubble sort algorithm using those numbers 27, 21, 12, 41, 38, 5, talking through line at a time what happens in the algorithm and the values of the variables as we go through. I've replaced some of the variable names with their actual values in the algorithm to show us what happens to them as we go through the algorithm. In the bottom right hand corner you can see the original algorithm in place for reference. So I'm going to talk through the algorithm one line at a time using the data 27, 21, 12, 41, 38 and 5. So the first line, function bubble sort and then data, just defines the function bubble sort and says it needs a parameter called data. Now we're going to provide it with an array as a parameter, our numbers we said already. The second line is the for loop, the actual part that loops through all the elements of the array. You notice that it has data.length -2 though. I'll talk about that in a second. We first have the I equals 0. So all arrays start with a 0 index. So the first element of an array has an index of 0. And then we're going to loop to data.length -2. Usually in a for loop, if we're looping through all elements of an array, we'd use -1 to get the last element of the array, because remember the last element will always be 1 less than the length. The length of this array will be 6. But the last element will be element number 5, as we can see in the table on the left. Well, we're going to loop one less time than that, so we're going to loop 0 to 4, because on a bubble sort, we compare pairs of data. So if we used -1 instead of -2, we'll end up with one number being compared against itself. And we shouldn't have to do that, because by the fifth time round, or by the time we get to element number 4, we'll already have sorted everything in place, so we shouldn't need to do that. The third line is the internal for loop. This is the one that actually does the sorting. Its job is to push the biggest number to the back of the data set we're looking at. This time round, the first time, it will push the biggest number to the back. And then the next time, the second biggest, and so on. You notice here that J will start with the value of 1, and it will keep looping until J has the value of data.length -1 minus I. So data.length -1 will be 5. At the moment, I has a value of 0. So we'll loop until J gets to the value of 5. The reason why J starts with the value 1 is because we always compare the value we're looking at, which is J, with the value before the previous one. So the first time round, J has the value 1. The element before that will be 0. So we start from 1 so we can compare 0 and 1. So the next line inside that for loop is if the current set of data -1, so J -1, so 0, is bigger than data 1. So we're checking if 27 is bigger than 21. If it is, which it is, we'll set a temp variable to have the value of data 1, 27. We'll overwrite the element number 1 with the one from before. So data element 1 is going to be equal to data element 0. So we'll swap. So 21 will now be replaced with 27. And the next line will make element 0 get the temp value, 21. So that internal 3 lines there, all that does is swap. From the next few times, I'll just say swap the values over. The next thing it does is takes to the next value of J, which will be 2. So the second time around, J now has the value 2. So we'll be checking if the data in element 1 is bigger than what's in element 2. In this case, we're checking if 27 is bigger than 12. Of course, 27 is bigger than 12, so we go inside the if statement and we do those 3 lines which swap the data around. Move on to the next value of j. The next value of j is 3. So this time we're checking if what's in the element before, which will be 2, is bigger than what's in element 3. So 27's in element 2, 41's in element 3. 27 is not bigger than 41, of course, so we don't go into that if statement, we don't swap them around, we leave them as they are. This is one of the inefficiencies of the bubble sort. Sometimes nothing will happen, there'll be no actions taken. So now j goes up to the next value, which is 4. So j has the value 4, and we're going to check if the value before j, 3, element 3, is bigger than what's in j, element 4. So we're checking if 41 is bigger than 38. 41 is bigger than 38. So go inside the if statement, swap them around, go to the next value of j. Now j has the value of 5, the last element in our array, and we're going to check if element 4, is bigger than what's in element 5. In element 4 right now is 41. In element 5 is 5. 41 is bigger than 5. Swap them over. Now we've come to the end of the first internal loop through, because j has the value of 5, and that it won't satisfy the condition of the for loop. And you notice that the biggest number is now at the end of the array. So now I now goes to the next value, which is 1. So I now has a value of 1. And we move into then the internal for loop for when I has the value 1. So now for j equals 1 to 5 minus 1. So I has a value of 1, so we take that away from 5. So we're going to go from when j is 1 to 4. You notice that's 1 less than the length of the array. That's because the biggest number has already been pushed to the back. That always happens with a bubble sort. The first time round, the biggest number always gets pushed to the back. And because it's already in the right place, we don't need to compare that anymore. That's done. So this time, we're going to check if what's in element 0 is bigger than what's in element 1. Currently, 21 is in element 0 and 12 is in element 1. 21 is bigger than 12, so swap them over. Move on to the next value of j. So now j has the value of 2, and 21 is in 1, and 2 has the value of 27. So 21 is not bigger than 27. Don't swap, don't go inside that for loop. Move on to the next value for j, which is 3. So now this time we're going to be comparing if 27 is bigger than 38. 27 is not bigger than 38, so don't do any swapping. Again, it's just showing some of the inefficiencies of a bubble sort, wasted loops. This time though, we're checking if the element number 3 is bigger than what's in element number 4, because j has the value of 4. So we're checking if 38 is bigger than 5. 38 is bigger than 5, so go inside that for loop, do the swap. So now we come to the end of that particular for loop, because now we'll reach the end condition for the for loop because j has reached the value of 4. And you notice that the second biggest number, 38, is now in the correct place. So we're now on to the third loop round for our external, the outside for loop, because I now has the value of 2. And we're going to the third line, and j has been reset to 1 again, and we're going to loop round to 5 minus 2. So to j equals 1 to the value of 3. So 1 less time than 1 before, because 38 and 41 are already in the right place. So the first time we're checking if what's in the value before j, so j currently has a value of 1, so what's in 0 is bigger than what's in value number 1. So at the moment in value number 0 is 12 of the array, and 21's in element number 1. So 12 is not bigger than 21, so we don't do any swapping. Move on to the next value of j. So j now has a value of 2. In the element before that is 21. Is 21 bigger than 27? No. Don't do any swapping. Move on to the next value of j. So j now has a value of 3. In the element before that is 27. In 3 is 5. 27 is bigger than 5. Do the swap. Next value of j. Now that meets the end condition for that for loop, because we're outside the boundary, because j is now bigger than 3. And you notice that the third biggest number is now in the right place. So we're now on the fourth loop round of our external loop. So I has the value of 3. Remember, we're looping to the I reached the value of 4, but at the moment I has a value of 3. And so now j has, and we're looping from j equals 1 to 5 take away 3. So from j from 1 to 2. So that means we're going to loop twice. So the first time round, if what's in the value before j is equal to or bigger than what's in value number 1. So we're checking if 12 is bigger than 21. We've done this before. 12 is not bigger than 21, so don't do a swap. Move on to the next value of j. So now we're going to check if what's in the element before 2, which is 21, is bigger than what's in element 2, which is 5. 21 is bigger than 5. Do the swap. Now j is now bigger than the criteria for the for loop, so we end that for loop because j now has the value of 3, so outside the condition, and we move on round. So this is the last loop around because I now has the value of 4, and the internal for loop we've got j equals 1 to the length of the array minus 1 minus I, so that would be 5 minus 4, so we're looping from j equals 1 to 1, so only one time round. And then in the if statement, it's looking at if what's in the element before j, so what's in 0, is greater than what's in 1. So at the moment, 12 is in 0 and 5 is in 1. Of course, 12 is bigger than 5. So in the 3 lines inside the if statement, you do the swap them over. So the element number 0 now has 5 and the element 1 has 12. J has now gone to the next value, which is 2, which is bigger than 1. End that for loop. I now goes on to its next value, which is 5, which is bigger than 4. End that for loop. The next line under next I is return data, which means the data gets returned back to the original code. Now the data should be the sorted value of the array. So the sorted array should go back to the main code, making numbers equal the sorted array. So if we were to run this, by the end of the code, numbers would equal the array, but in the correct order, which would be 5, 12, 21, 27, 38, 41. Why not give it a go creating this algorithm in a language of your choice, like C# or Python?